Sorry. I'm trying to share my screen at the moment. It's refusing. I don't know why. So anyway, hopefully you can see my screen. Okay, thank you for coming back anyway. So as I was saying, I'm trying to write this thing as a factor, right? So having your intercept, your factor loading plus your factor, right? So basically your BI, so I have this one over here, and then I have 1 minus alpha BI F, where F is our factor, right? So basically this is how you can write it down. So if so if the factor have no factor loading, right? So if let's say maybe your beta is going to be equals to 0. So this thing, you can basically call this thing your A plus your B times your F, right? So if your B is going to be, if your B is going to be here equals to 0, it simply means that this one over here is going to be your risk-free. Okay, so it's going to be your risk-free return. I can say risk-free return, or you can just say your risk-free, because he's an equation of return, so it's going to be your risk-free return. But then how can this thing be equals to B? At what point can this thing actually be equals to B, right? So alpha B beta I plus 1 plus alpha beta J can only be equals to 0 when? So this can only be equals to 0 when your alpha is going to be equals to what? It's going to be equals to BJ over BI plus BJ. Is it going to be like this? No, man, this one's going to be negative because it's going to go to the other side. Made a mistake. It's going to be 1 minus. Okay, so yes, minus BJ. So basically if your alpha or your weight of I is going to be equals to minus BJ over BI minus BJ, then we know that your return are going to be 0. So how, again, so if this is the case, we can basically take this thing back to our, okay, so take this thing back to our equation, right? So we can write our returns of a portfolio. Yeah, so basically this is, yeah, so the returns of a portfolio as going to be, so in terms of theta, we can just write this thing. So you can just write Okay, there are no questions. So for this one, 1 minus alpha. So you will basically have what? You will basically have minus bg minus bi plus bj. And then you will have minus bi over bi minus bj. aj. And then remember that if our alpha is going to be 0, this whole thing is going to be then this thing is going to be 0. So you're going to see plus 0. So there is no need for you to write plus 0. So basically this is your risk-free rate. So basically this is your risk-free rate because this thing is not affected by effect. So you can basically call it a risk-free rate. So you can just say this thing is going to be your risk-free rate, right? So if this thing is going to be your risk-free rate, okay. Anyway, yeah. So how can I really explain this? So you have found your risk-free rate now. So your RP is going to be equals to RF when the weight of A is going to be equals to minus BJ over BI minus BJ. So in some questions, they can try to like simplify this. So that's fine. And then if this is not the case, so if so if the weight of A of I, sorry, of I, so this is the weight of I, right? So if the weight of I is equals to this, and again, and this thing is not going to be equals to risk rate, then it simply means that there is going to be an arbitrage opportunity. So, and then we can go back again to how we can take advantage of an arbitrage opportunity, right? So anyway, so what they use, so instead of writing, okay, so instead of writing it as RF, they used lambda 0 to denote a risk-free return. So they basically use lambda 0. So they basically use lambda 0 to describe a risk-free return. So this one is going to be your risk-free return. So this is the same as RF, right? So if your lambda is not going to be equals to RF, then there is an arbitrage opportunity. So there is an arbitrage opportunity. So in terms of your risk-free rate, so you're going to have lambda equals to 0. It's going to be equals to minus bj. It's going to be j, bi, bj, ai plus bi. Actually, yes. So you're going to have again bi minus bj. So did I make any mistake somewhere? I hope not. And then you can try to simplify this. How do you simplify this? Or you can just try to put them together. Let's see. You have A here. You have A, J. in my thinking, this is what my first instinct takes me. So I'm gonna write it like this. I'm gonna say BJ minus BI over AJ over BI minus BJ. Equals to lambda. Then you can say lambda times BI minus BJ. It's going to be equals to, I feel like I have missed something. And then did I miss a sign somewhere? I remember one of them have to be positive.
Yes, that's the only thing in the book. It just says AIBJ, so it should just be positive the first term on the right hand side.
Again, which this one is positive.
Yep, and the rest is perfect. Well, you use BI minus BJ, so it would just swap, but it comes down to the same thing though.
Oh, okay. Oh yes. Oh yes. So basically, it's the same thing. Yes. In the book, actually, they did use BI minus BJ. So I think I missed a sign somewhere. But then anyway, you can take note of this. I'm gonna say note here. BI minus BJ. Okay, it's fine. But then at the end of the day, what you will find is an equation that looks like this. Where did I write it down? I think I should have written it down. Anyway, okay, it's fine. I'll just have to make peace of this and move a little bit down. So anyway, for A, so at the end of the day, so what they did was to find your thing. Like they went and find your intercept. So your intercept, let's say for I, for A. So again, they say that is going to be lambda 0 plus BIC, where C was going to be something like this, was going to be something like J. Is it J? It's going to be AI minus lambda 0 over beta I, basically. And okay. I'm sorry, I have to find where I wrote this thing first. When I was preparing, sorry. I'm sorry for that. Okay. So anyway, I think I'll have to cancel this thing or take it down. In my proof when I did this thing earlier on. So okay, and so what I had at the end. So I had simplified the returns right before I can get here. Before I can get here. So my returns were alpha returns of I times B So this is when I have simplified up there. So and then I had bi bj minus b bi minus ai, I think it's b aj, aj bi over bi minus bj. So the same thing applies. So this thing is gonna be risk-free. So ideally, you will have to call this thing a risk-free rate, right? So, or this thing has to be equals to a risk-free rate. So you can give it a name. You can say that that's gonna be lambda 0. If this thing is not gonna be equals to risk-free rate, then there is an arbitrage. Okay, so there is an arbitrage opportunity. So it's possible that this so it's possible that this thing cannot be so it cannot be equals to 0. So that is why they do not so that is why they do not explicitly write it as equals to risk-free rate. That's why they use lambda 0, because it's possible that lambda 0 can be equals to any other value except the risk-free rate. And if that's the case, then you know that there is an arbitrage opportunity. But then if so that's why they write it as lambda. But then we know that lambda should actually be equals to risk-free rate. So if our lambda is going to be here equals to risk-free rate, so you can write our lambda as going to be equals to alpha alpha ai or you can actually put negative. Sorry. Okay, so you can so you can write it down like this. So you can see that this side you have j. Again, I'm like bj minus bi. Here you have bj minus again I'm like bi minus bj. So you would want to make it negative. So you would have equals to negative alpha ai bj over bi minus bj minus aj bi over so it will depend on how you want to put it down yourself. So again, so if you want, you can basically write it like this. You can see that alpha ai bj over bj minus bi is going to be equals to plus aj bi over bi minus bj. So you have bj here, bj bi basically. So it will depend on how you so on how you like simplify it yourself. So at the end, you would want to make what? So at the end, what you will have minus aj bj plus, it's not going to be plus. So this one's going to be plus. Sorry. So you're gonna have plus aj bi is going to be equals to lambda 0 bi minus bj, and then you're gonna so you're gonna put the one which have like the common, so the one which are of the same asset together. Then you're gonna have aj minus lambda 0 over bj. You're gonna be equals to what? It's gonna be equals to bi minus lambda 0 over bi. So it's supposed to be I. So this one is for j, this one is for I. So anyway, you're gonna I'm gonna use a bigger pen. let's say you let AI minus mu 0 equals to BI here equals to 0. If this is the case, then your your intercept is gonna be equals to lambda 0 plus BI times C, where C is basically this thing over here. So if you're gonna make, I'm gonna say J. So let's say this thing is JJ. So JJ. So if that's the case, then you're gonna have your A like this. Anyway, so when we go back to the returns, to our returns of I, we know that again. So we know that AI is gonna be equals to B, BI, F, right? So F is that single factor, and then we put our A there. So our A was lambda 0 plus, and then this thing has a factor B. So you're gonna have B times C plus F. So this thing over here, you can call it what? You can call it is called a factor premium. It's called a factor premium. A factor premium. So normally when they write a factor premium, they write it like this. They write it like this. Since the I, they write it like this. They write it as lambda 1. Okay. Yeah. So basically, this is how you like prove this thing. I'm sorry for taking this much long. I was lost somewhere. I think I made a mistake. So anyway, I'm sorry. I thought I was gonna go solo and I would succeed. So anyway, so this is how you write your. Okay, so this is how you write your equation. So remember that this thing we say that it's gonna be a risk-free rate, right? So when you answer questions of this nature, where they ask you about arbitrage, again, I think I have 2 questions over here. 3, okay. I have 3 questions actually. So you are going to then you should always keep in mind that your lambda 0 should be a risk-free rate. He's not always gonna be equals to risk-free rate, and if it's not going to be equals to risk-free rate, then you know that there is an arbitrage opportunity, right? So we can try this few, so these few examples so that we can learn a little bit. So anyway, so assume that the expected rate of return on security can be described as the following. So I forgot to mention something as well, that when you also have more asset, so if you have more factors, right? So if you have multiple factors, the returns of I is still gonna have lambda 0 equals to beta I times lambda 1 times beta I. You can just say 1 here, beta 1, 2, lambda 2 plus those minute ones. And I forgot to put the expectation sign over here. So if that's the case, you can write it like that, right? So assume that the can be described is the expected return of again, I'm like one security that can be described by the following factor thing. So where Bij term are the coefficient of the model. Again, so of the model more specific for each security, and lambda J term represent the risk premium for each of the factor underlying security return. We also know that there are security A and B have the following risk and return information. So based on the above risk and return information, what is the equilibrium value of the I'm like of lambda I or of lambda James? So basically what they're asking you right now is to find your J's. They want you to find your lambda J's. There's a question. Oh, okay. Says all good. So anyway, to find this, we're gonna use this equation over here to find these values, right? So anyway, the returns of A is gonna be equals to lambda 0 times the beta for 1. So the beta for 1 is gonna be 1,5 times lambda 0, and then the beta for the other ones is gonna be 1. So I'm gonna put lambda 2. The same thing can be said about B. We have lambda 0, lambda 1 plus lambda 2. The returns again of C, you can find lambda 0, and the beta is going to be 0,8, lambda 1 plus 0,7, lambda 2. It's so much easier if you use your metrics to solve these things. So if you can say you're going to have 1, 1, 1, 1,5, 1, 0,8, 1, 1, 0,7. So the returns of A is going to be 0,145, 0,13, 1, it's going to be 0, 0,109. So, and then you can try to solve this thing. Okay, we can try to solve this thing together. So we have 1, 1,5, 1, 0,145, right? And then you're going to say row 1 minus row 2, like row 2 minus row 1. So you're going to have 1 minus 1 is going to be 0, 1 minus 0,5 is going to have negative 0,5, 1 minus 1 is going to be 0. And then negative 0, what? 0.15. I have to confirm. Yes, and then 1 minus 1 is going to be 0. Negative 0,7, negative 0,7, negative 0,3, actually negative 1, 1,0, 1, again is 0,45, 145. Then you have 0,036. So a little bit further. 0,45, 145, 0, negative 0,5, 0, 0,0115. So here you're going to have R3 minus 0,7 over 0,5. R2 going to have 0, going to have 0. So 0,3, 0,036 minus 0,7 over 0,5 times 0, times negative 0,015. 0,057. Okay, so basically, and then from here you can see that lambda 3 is going to be equals to 0,057 minus 0,3. It's supposed to be negative. -0.19. And please confirm if this is correct. I'm coming. Sorry. Yeah, so basically this is how you find these answers. So you can do the same for lambda 2 and then for lambda 3. I'm like for lambda 1, sorry. Yes. Sorry. So so suppose that there are n assets whose return are governed by one factor. So we are looking ahead one factor. So this question says, according to the equation, prove that there is a constraint. Oh, so this is basically the proof we have done. So here they want you to use the proof. Actually, I wanted to do the proof here, but so basically you just have to go redo that proof. The next question. Assume that there are two index factor described by this thing. I'm not sure if this is visible. Yeah, it doesn't make it visible, so I'm going to cancel it. So the parameters have the have the same as studies in the lecture. They study this table, and they ask you to like state the APT. So find the equation of the plane that describe the equilibrium return. So again, and so when they ask those things, again, so they actually just want you to find again, I'm like delta. No, it's not delta. Lambda 0, lambda 1, lambda 2. So there are, so there are two factors. So this is how much, so this is how many you should find. And again, so remember that this equation is going to be like this, So this is the equation of the arbitrage model, right? So you're going to write it like this. Beta plus beta I2 lambda 2. So if this is the case, again, you do the same thing. You can you're gonna have your returns of like 3 assets. So you have the returns for X. That is gonna be 10%, 0.1, lambda 1. I mean again lambda 0. Factor 1 is gonna be 1. So you're gonna have lambda this. You're gonna have 0.5 lambda 2. And then 0.13 lambda 1. I'm like lambda 0, 3, lambda 1 plus 0.2 lambda 2, 0.1 lambda 0 plus 3 lambda 1 minus 0.5 lambda 2. And then you basically solve this thing until you find your can solve these values. So do we have any questions for now? Or do you want me to find find this value? Or are we fine if I can stop you?
And about the others, but I'm all good. Thank you, sir.
Okay. Yeah, so this one is the last session for Kenya. So this one is the last one. So today we were supposed to do chapter 6, 7, and 8. Oh, and in the last session, which cancelled, someone asked a question. I think it was Neil. It was about what? It was about, I forgot, but then I will check it out and then I will get back to you. I think it was based on what? I think it was on CAPM. And sorry for the last session, but there was noise, I was basically not very audible. So any questions? Okay, so if you have any question, you can private message me. If you have any papers, you can also send them on the group. We can do them together. So, okay, thank you. Oh, and also, before we can go, before we can leave, before we leave, before you can go, guys, I'm gonna have another session 1 again, because I'm not sure when the exam is gonna be. So I'm gonna have another session 1. So since you guys already have paid, you can re-attend it. I want it to be closer to the test, and I will be focused mostly on looking at question papers. So, but then the rest of the sessions will go as planned. But then once they confirm the date of the exam, I mean, like, yeah, or of the exam, we will have another session similar to this one, but then we're gonna be looking at more questions in detail, like not like I am doing right now. So anyway, thank you.